So what's going on, you guys? My name is John.
And my name is Sarah. And today, we are going to talk about the 6 trigonometric ratios.
And it's the application to real life. So just hold up, you guys, because we'll be talking about that after this intro. So welcome back, you guys, and as I've said earlier, today we're going to talk about the 6 trigonometric ratios. So what are the 6 trigonometric ratios? How can we use it to solve mathematical problems? And most importantly, how can we use it in real life? So what are the 6 trigonometric ratios? So these 6 trigonometric ratios are the basic of trigonometry, which basically talks about right angle triangles or right triangles. So when you are trying to find a missing angle or missing side of the right triangle, you can use the 6 trigonometric ratios. So what are the 6 trigonometric ratios? So the 6 trigonometric ratios are the sine, cosine, tangent, cosecant, secant, and cotangent. So we use this memory device to help us remember these 6 trigonometric ratios. So these are the so, ka, tawa, tu, sha, kao. So SOH stands for sine, opposite over hypotenuse. Then ka, CAH stands for cosine, adjacent over hypotenuse. Then tawa, TOA stands for tangent, opposite over adjacent. Then chu, CHO, cosecant, hypotenuse over opposite. Then sha, secant, hypotenuse over adjacent. Then kao, cosecant, opposite over adjacent. So without further ado, let's do some examples.
Consider a right triangle ABC where C is right angle. Given the value that side C is 9 cm and side A is 7 cm, find the value of angle A. The given values are 9 cm, which is the hypotenuse, and 7 cm, which is the opposite side of the angle A. If the given are the hypotenuse and the opposite side, which in this trigonometric ratio are we going to use? Based on SOHCAHTOA, we're gonna use sine. Then, let's start solving. Sine theta equals the opposite side over hypotenuse. Let's substitute the value of the opposite side, which is 7 cm, and the value of a hypotenuse, which is 9 cm. That will come up to sine A equals to 7 over 9. Upon solving, using the calculator, the answer is 51.06.
Hi guys, so this is our second example. So if you guys are to encounter a problem like this where you are given one angle and one side, so what you're going to use is the 6 trigonometric ratios, which is what I'm talking about today, right? So consider a right triangle ABC where C is a right angle. So if angle B is 50 degrees and side C or the hypotenuse is 9 cm, so what is the measure of side A? So when you look at the illustration, side A is actually the adjacent of angle B. So our given basically is an adjacent side, the angle, and the hypotenuse. So what are we going to use? Which of the 6 trigonometric ratios are we going to use? So basically you have A and H. So what we're going to use is, that's right, cosine. So CAH, cosine adjacent over hypotenuse. So let's try and solve this. So cosine adjacent over hypotenuse is cosine 50 degrees is equal to adjacent, which we're going to write as small letter a, over the hypotenuse, which is 9 cm. So just cross multiply this, then you will have A is equal to cosine 30 degrees times 90 centimeters. So let's just plug this in our calculator and we'll have the answer of 7.79. So that's it for a small example.
Next example. Given that angle B is 40 degrees and side B is 8 cm, what is the value of side A? The side A which we are looking for is the adjacent side of angle B, which is 40 degrees, and the other given is side B, which is 8 cm. In that case, we are going to use tangent in solving the value of side A. Let's start solving. Tan theta is equal to opposite side over adjacent side. Let's substitute the value of opposite side, which is 8 cm, and the given angle, which is 40 degrees. That will come up to tan 40 equals to 8 over 8. Let's perform cross multiplication. That will come up to tan 40 times A equals to 8. For us to know the value of side A, let's divide both sides by tan 40. Then, let's divide 8 by tan 40 using calculator. The answer is 10.44 centimeter.